Good afternoon, everyone. So, today we are going to discuss regarding nuclear reactor. In the previous classes, we have seen that from current electricity, we have discussed two most important concepts. One was potentiometer and the application of potentiometer for comparing the EMF of two cells. And another question that we have discussed was to determine the internal resistance of a cell. Now, after that, I have started nuclear physics, and in nuclear physics, yesterday itself, we have discussed regarding law of radioactive decay, and we have shown that the decay is in exponential nature. So yesterday I have started one topic, that is nuclear reactor. So today we'll continue the topic. After finishing the topic, we'll move on to SAQ chapter. So I hope everyone is ready with book and pen. So let us discuss. So yesterday I have discussed regarding nuclear reactor. Nuclear reactor. So what is nuclear reactor actually? So it is a device. It is a device in which what is happening? Controlled fission reaction. या फिर controlled fission process takes place. Process takes place. And further, we have discussed the components of nuclear reactor. What were the components of nuclear reactor? How many components were there? We have seen that there are 5 components. 5 components. What are those 5 components? First one was fuel. And the other component was moderator. What was the third component? Third component was control rods. What was the fourth component? Coolant. And what was the fifth component? Shielding. Shielding. These were the 5 components that we have discussed yesterday. What was the fuel that we'll be using? We'll be using nuclear fuel. What is the name of that fuel? We'll be using 92 uranium 235 as the fuel. And what was the work of moderator? I said that whenever fission process is taking place, neutrons will be emitted. Those neutrons will be moving with very high velocity. In order to slow down the neutrons, what we'll be using? We'll be using moderator. So moderators are used for to slow down fast moving neutrons. Fast moving neutrons. Next, once the neutrons are slowed down, what will happen? Those neutrons will do fission process with another uranium or get attached to another uranium. Again, what will happen? Due to this reaction, further 3 neutrons will be emitted. This process goes on. In order to control this process, what we'll be using? We'll be using control rod. These are neutron absorbing material. Neutron absorbing material. So what were the examples for this moderator? I said that heavy water, and graphite. These 2 things are used for moderator. And further, what is the material that we'll be using for control rod? What are the neutron absorbing material? I said that it was cadmium. Cadmium. So these were the things that we have discussed yesterday. What was the work for coolant? Whatever heat energy, whatever heat was generated in the nuclear reactor, all that heat was absorbed by coolant, and that was used for running a turbine. Through that, we'll be getting generating electricity. And why we will be using shielding? In order to protect the external environment from the harmful radiation. So these were the things that we have discussed in yesterday's class. Now let us continue further. After writing this component, what are those 5 components? Fuel, moderator, control rod, coolant, and shielding. After writing these components, what you are supposed to do? You are supposed to write the working of nuclear reactor. Working of nuclear reactor. Nuclear reactor. So what are the points that you are supposed to write in case of working of nuclear reactor? Means the first point is, the first thing you are supposed to write is, whenever uranium undergoes nuclear fission process or fission process, when 92 uranium 235 undergoes fission process, what will happen? क्या होता है यहाँ पर? What will happen? Neutrons will be emitted or liberated, which will be moving with very high velocity. So neutrons are liberated and are moving with very high velocity. So what we'll be doing next? What was the work of moderator? Moderator का काम क्या था यहाँ पर? To slow down the fast moving neutron. So what is happening there? These neutrons are slowed down by moderator. Once the neutrons are being slowed down, again further what will happen? They will become thermal neutrons, and this fission process goes on. Due to this fission process, a huge amount of energy is generated. Now, in order to control fission process, what we'll be using? Control rods are used. Now, once the process has been controlled, and we know that huge amount of energy is generated, heat energy is generated, in order to absorb that heat energy, what we'll be doing? We'll be passing coolant through that system. So what is happening next? Coolant is used to absorb the heat generated in the nuclear reactor, and it is used to run the turbine. This is the working you are supposed to write. Once that steam is used for running the turbine, again electricity will be generated from that turbine. See here, what we have did, we have just discussed what is nuclear reactor. What is a nuclear reactor? It is a device in which controlled fission process takes place. And further, we have discussed 5 components. What are those 5 components? One is fuel, another one is moderator, third one is control rod, fourth one is coolant, and fifth one is shielding. Next, we have written the working process. If you combine all the components, it will become a working process. Next thing you are supposed to do is draw the diagram for this. For drawing the diagram, you will be getting marks. If you leave the diagram, you will miss the marks. You won't get full marks. So here there are 2 diagrams. I prefer this diagram because by looking at the diagram, you can write down the components. So let us see what is the diagram. I am drawing the diagram for nuclear reactor. Everyone carefully see here. Here I am considering fuel rods. These are my fuel rods made up of, these are made up of metal, aluminum metal, in which fuel cells are there. 92 uranium 235. I have considered 3 fuel rods. Here, this entire chamber is filled with moderator. What is the work of moderator? Moderator is used for slowing down the fast moving neutron. So these all are moderator. Entire thing is filled with moderator. What is this? This is fuel rod. What is inside this chamber? Moderator. Okay. Next, we are supposed to consider control rod. So see here, I am taking control rod somewhere here. These are my control rods, which can be moved up and down. By moving this up and down, we can control this process. These are called as control rods. What are these things? These are control rods. Control rods. Next what I am doing? See here. Draw a chamber, something like this. From here, we'll be drawing some pipes. Here one pipe is there, which will be passing through water bath. Again, this pipe is attached to a pump. Here it will be a pump. Again, this is connected to this nuclear reactor. Why we are using this pump? Why we are using this pipe means coolant is passed through this. What is that? In order to pass coolant, this coolant will pass through this entire nuclear reactor and it will absorb large amount of heat. And what it will be doing? Again, it is allowed to pass through a water bath. What is there inside this? Inside this, there is a water. Whenever this coolant is passed through a nuclear reactor, it will absorb all the heat energy, and that heat energy is utilized for generating steam here. From this water, what is developed? Steams is developed. Now these steams are utilized. Steam to turbine. What is happening here? This steam is utilized for running the turbine. I prefer you to draw this diagram. Otherwise, you can draw one basic diagram which is available in your question bank. So see here, this is the diagram for nuclear reactor. Here we will be having fuel rod. Inside this we will be having moderator. And these are called as control rod. And coolant is passed through this pipe. And what coolant will be doing? It will be absorbing all the heat energy generated in the nuclear reactor. Next, due to this, what will be happening? Steam will be generated here. This steam is used for running the turbine. By this, we finish two important concepts from nuclear reactor. One concept was regarding law of radioactivity decay, and the other concept is nuclear reactor. Out of these two questions, you can expect one question in your annual examination. So carefully read these four LAQs. What are the four LAQs that I have discussed? Potentiometer, Kirchhoff law, nuclear reactor, law of radioactivity decay. If you are perfect with these four LAQs, 99.9%, two LAQs will be there in your annual examination. I hope you understood this concept of nuclear reactor. So now let us discuss another important chapter for your annual examination. You may expect one FAQ from this chapter. There are only four questions, 4 or 3 questions. Out of the 4 or 3 questions, one question will be there in your annual examination. So what is the next chapter that I am going to discuss is electromagnetic induction. Electromagnetic induction. So see here, in this chapter, we'll be having two numericals and one or two short answer type question, 1 or 2 questions concept. So out of this 2 numerical or 1 or 2 concept, you will be getting one question definitely in your annual examination. First of all, I will be discussing the numerical. Once I discuss the numerical, I will be giving the important question that may be asked in your annual examination, that is regarding eddy current. So first of all, I will be discussing numerical. After that, I will be discussing the eddy current answer. Now here, carefully write down this numericals. So first numerical. So I will be dictating or I will be writing the question here. Please note down this question. First numerical is current in a circuit falls from 5 amperes to 0 amperes in 0.1 second. In 0.1 second. Full stop. If an average EMF EMF of 200 volt is induced. Estimate the self-inductance in the circuit. Estimate the self-inductance in the CIR circuit. See how you are supposed to answer this. First of all, write down the given quantities. What are the given quantities here? Answer. Very important numerical. You can see the previous year question paper. You will be seeing this question there. I think it will be around 16th or 17th question you can find in previous year question paper. So what are the things given here? Current is changing. I is changing from where to where? 5 amperes to 0 amperes. Current is changing from 5 amperes to 0 amperes. So I can write change in current DI as 5 amperes, because 5 minus 0 will become 5. In how much time? I am taking time dt is equals to 0.1 seconds. So current is changing from 5 amperes to 0 amperes. In how much time? 0.1 second. Next, what he has given? If an average EMF of, so what is the value of average EMF he has given? E is equals to how many volts? 200 volts is induced. So current is changing from 5 ampere to 0 ampere. In how much time? 0.1 second. Whenever an average EMF of 200 volt is induced. Now what he is asking you to determine? He is asking you to determine self-inductance. What is the symbol for self-inductance? We know that self-inductance is given by symbol L. He is asking you to calculate the value of L. You will be getting the marks for writing the given things. Don't directly do the problem. Write down the given thing. Next, what you are supposed to do? You are supposed to write down the formula. What is the formula here? Formula. What is the formula for this particular given thing? We know that average EMF induced is given us. I am taking modulus because negative sign will be there. Negative sign represents what? Opposite direction. So whenever I am including this modulus, I can neglect that negative sign. EMF E is given as L into di divided by dt. For writing this formula, you will be getting 1 mark. For writing given thing, you will be getting 1 mark. For writing the formula, you will be getting 1 mark. So what is the formula for average EMF in case of self-inductance? E is equals to L into di by dt. We are supposed to determine the value of L. Now see here, let us substitute the value of E. What is the value of E given? 200. Value of E given is 200. We are supposed to determine the value of L. And what is the current? Change in current is how much? 5 amperes. 5 amperes. And how much in how much time? 0.1 second. 0.1 second. How I can solve this? See here, I am solving that answer here. This 0.1 can be written as 1 by 10. So this will become 200 is equals to L into 0.1 can be written 1 by 10. So if I take the 10 to numerator, it will become what? 5 into 10. So what this will become? This 0 and this 0 get cancelled. 5 1 and 5 4. So this will become L is equals to 4. You should write the units. If you are not writing the units, you will lose the mark. 4 Henry. 4 Henry. So this is the end of this answer. For this answer, you will be getting 4 marks. This question is for 4 marks. See here. So what we did in the question he has given, current is changing from 5 ampere to 0 ampere. In how much time it is changing? In 0.1 second it is changing. And what is the EMF induced due to this? 200 volt of EMF is induced. What he is asking you to calculate is asking you to calculate the self-inductance. I know, first of all, write down the given quantities. For writing the given quantities, you will be getting the mark. For writing the formula, you will be getting the mark. For doing this, you will be getting the mark. And finally, for writing the answer, including the unit, you will be getting the mark. So this is the first important numerical from this electromagnetic induction chapter. I hope everyone might have copied on this so that I can move for another numerical. So I am turning the page. So let us see the next numerical in this chapter. So let me take the question. Next question, second question. Please note down this question. A pair of adjacent coils, a pair of adjacent coils, has a mutual inductance, See here, in previous problem we have discussed regarding self-inductance. In this problem, what we are going to discuss? We are going to discuss regarding mutual inductance. So how much is the mutual inductance given in the question? Mutual inductance of 1.5 Henry. Okay, very good. What is the next thing he has given? If the current in one coil, current in one coil changes from 0 to 20 amperes, 0 amperes to 20 amperes in 0.5 seconds. In 0.5 seconds. Okay. Now what he is asking? What is asking in the question? What is the change in flux? What is the change in flux with the other coil? With the other coil. Please note down this question and try to solve this. In previous problem, what was there? There was a self-inductance. But in this problem, what is there? Mutual inductance is there. Please try to solve this problem. Again, same thing here given. A pair of adjacent coil has a mutual inductance 1.5 Henry. If the current in one coil changes from 0 amperes to 20 amperes, in how many seconds, how much time he has given? 0.5 seconds. What is the change in flux with the other coil? Please try to do this. Try to do this problem. Okay. First of all, what you are supposed to do? You are supposed to write down the given quantities. I am writing the answer. What are the given quantities here? See here, mutual inductance is given. Mutual inductance is represented by symbol M. How much he has given mutual inductance? 1.5 Henry. What is the next thing he has given? Current in the coil is changing from 0 amperes to 20 amperes. Again, I will be taking positive sign. So I am writing DI, change in current, how much? 20 amperes. In how much time? dt is equals to how much seconds? 0.5 seconds. What he is asking you to determine? See here, he is asking you to determine the change in flux. He is asking you to determine change in flux. So that is nothing but d phi. He is asking you to determine what? This is called as change in flux. Change in flux. So these are the given things. Next, what you are supposed to do? You are supposed to write down the formula. Again, same formula. Instead of self-inductance, what you are supposed to write? You are supposed to write mutual inductance. So I can write the formula as E is equals to, otherwise I will be writing formula here. Formula. Because you will be getting marks for this. Formula. What is the formula? Average EMF. E is equals to, in the previous case, what we have written self-inductance. But here, what you are supposed to write, mutual inductance. M into di divided by dt. See here, we know the value of M. We know the value of di. We know the value of dt. But here we'll be getting what? Average EMF or induced EMF. But what he is asking you to calculate? Change in flux. So we know that average EMF or induced EMF is given as E is equals to d phi by dt. So if you substitute this value here, what this equation will become? This formula will become d phi by dt is equals to M into di divided by dt. So I can cancel this dt and this dt. Finally, what is the answer I will be getting? Here, finally, I can write one equation. D phi is equals to M into di. See here, after writing this formula directly, you can go for this. Your wish. After writing this formula directly, if you remember, you can go for this, or you can derive this. Just it will take hardly 30 seconds. So see here, let us substitute the values. d phi is equals to, what is the value of m given in the question? 1.5 into what is the change in current given in the question? 20. So this will become how much? d phi is equals to 1.5 into 2 will become 3. And another 0 is there. This will become 30 Weber. Remember this unit. For units, you will be getting the marks. So this is the final answer. So this is the next numerical from the electromagnetic induction chapter. As in the previous examination, they have already asked the eddy currents question. So there is a huge probability that they may ask one numerical, either this numerical or this numerical for upcoming examination. I hope you understood these numericals. Okay, please note down this so that I can move on to the next important concept or important question from this chapter. Okay. So next important concept from this chapter is eddy currents. Eddy currents. Eddy currents. See here. How these eddy currents are generated, where these eddy currents are generated means, let us consider two magnets. Assume that there are two magnets. In between these two magnets, what I am doing, let us consider these two magnets. Here there is one magnet of North Pole. Here I am having one more magnet of South Pole. Now what I am doing, a constant magnetic field or varying magnetic field? Constant magnetic field. Okay. Next, what I am doing, I am taking a metal plate. I am taking a metal plate here. And I am making this metal plate to oscillate. I am making this metal plate to what? Oscillate between this magnet, two fixed magnets. This magnetic field is changing or remaining constant? It is remaining constant. But what is happening whenever I am making the metal plate to oscillate between this magnet? What is happening? Initially, when the metal plate is coming inside the field of bar magnet, what is happening? Magnetic flux, that is nothing but magnetic field line. Magnetic field line passing through this metal plate is initially increasing. As this metal plate is moving away from that particular region, number of magnetic field lines are decreasing. That is called as magnetic flux. So there is change in magnetic flux. Whenever there is change in magnetic flux, what will happen? An EMF will be induced. How it will be induced? Because there are some currents. Sometimes it is going in clockwise direction. Currents are flowing in clockwise direction. In another time, when it is moving away, the currents are flowing in anti-clockwise direction. So these currents which are developed inside a metal which is oscillating between two bar magnets is called as what? Eddy current. I hope you understood what is the meaning of eddy current. So wherever there are two bar magnets, whenever I am oscillating a metal plate through the two bar magnets, what is happening? The magnetic flux is changing. Due to the change in magnetic flux, what is happening? Eddy currents are generated in this metal. I hope everyone understood the definition of eddy current. So in your examination, he'll be asking what are the uses for the uses of this eddy current. So you are supposed to write 4 uses. If you are writing 4 uses, it will be sufficient. What are those 4 uses are means? First one, you can write magnetic braking in trains. Magnetic braking in trains. Magnetic braking in trains. What is the next use, second use of this eddy currents? Electric meters. In electric meters. Electric meters. What is the next use of this eddy current? Third one. Induction furnace. Induction furnace. What is the last? If you are writing 4 uses, it's enough. You can write n number of uses. But for main examination, if you are writing 4 uses, you will be getting the sufficient marks. 4 marks here. What is the last one? I have written magnetic braking in trains, electric meters, induction furnace. Another one is electromagnetic damping. Electromagnetic damping. Electromagnetic damping. See here, how these eddy currents are utilized in magnet braking of trains. See here, what is happening? Below the rails, there will be some electromagnets. Whenever we are activating that electromagnet, what will happen? Eddy current will generate, and this will oppose the motion of magnet train. It will oppose the motion of train. Due to that, what will happen? Train will stop. So, acha, see here. Even if you are not writing all the theory, if you are writing these 4 points, what are those 4 points? Magnetic braking in trains, electric meters, induction furnace, and electromagnetic damping. Even if you are writing these 4 points, you will be getting 2 marks. Even you don't write the definition for this or explain this, at least you are writing these 4 points, you will be getting how many marks? 2 marks. But if you are explaining, you will be getting another 2 marks. See here. Why? How eddy currents are used in magnetic braking in trains? See here, whenever inside the rails, what will be there? Electromagnet will be there. Whenever I am activating that electromagnet, what will happen? Eddy current will generate, and it will oppose the motion of the train, due to which the train will stop. This is the thing you are supposed to write in case of magnetic braking in trains. Next one. Just a minute. I think you are not able to see the screen there. I will try to adjust. Okay. See, so I hope you understood why how these eddy currents are utilized in magnetic braking in trains. What is the next thing? Electric meters. I don't know whether you have seen or not. Initially, in olden days, we will be having electric meters in which there was a shiny disc that will be rotating there. Nowadays, we are having digital meters. So, in that also, electric meters also, which phenomena is utilized? Eddy current is utilized for running that shiny disc. If you are having some old houses, in old houses, you can see this type of electric meter. There will be a shiny disc continuously rotating. Whenever you are increasing the use of electric current, what will be happening? It will be rotating with very high speed. That is also due to what? Eddy current. And what is the next one? Third use of this eddy current which we are utilizing? That is nothing but induction furnace. What is happening in the induction furnace? Actually, this is used for melting the metals. So whenever eddy currents are generated, due to that, what will be happening? A huge amount of temperature increase will be there. Due to the increase in temperature, what will be having? Whatever metals we are placing in that induction furnace, what will be happening? It will start to melt. So this is also an application for eddy current. Next, what is the next one? Electromagnetic damping. So you might have seen galvanometers. In that galvanometer, there will be one coil which will be oscillating here. So in those type of instruments, what these eddy currents are used? Eddy currents are used for bringing back that metal coil. In order to bring that coil to original position, what we'll be using? We'll be using eddy current. So these are the 4 uses of eddy current. What is the first use? Magnetic braking in the train. What is the next use? In electric meter. And what is the third use? Induction furnace. And what is the fourth use of this eddy current? Electromagnetic damping. Okay. I hope you have understood this answer, and you will write down this answer in your annual examination. So by this, we have finished most important concepts from which chapter? Electromagnetic induction. Either you may get this numerical or this numerical in your examination. Otherwise, you can expect this SAQ, which was asked in previous examination also. This SAQ for your annual examination. I hope everyone understood this answer. Let us move on to next important question from another chapter SAQ, that is semiconductors. Another very easy chapter. Hardly there may be 4 or 5 SAQs. Out of that 4 or 5 SAQs, you may expect one SAQ as question number 18 in your annual examination. Okay. So here also we'll be discussing important SAQs for your annual examination. So let us start with half wave and full wave rectifier. Half wave and full wave rectifier. Let me see the time. Yeah, it's sufficient. See, first question that we are going to discuss in semiconductor devices is what is rectification? What is rectification? So first, the concept which I am going to discuss is rectification. Rectification. What is the definition of rectification? The process of converting AC voltages to DC voltages. In some book, you will be finding AC to DC also. But what is this? The process of converting AC voltage to DC voltage is known as what? Rectifier. Rectification. And the device used for it is called as rectifier. How many types of rectifiers are generally that we will be discussing in our syllabus are? One is called as half wave rectifier, other one is called as full wave rectifier. Carefully listen this class. Definitely you may get this question because this question was previously asked in your main examination. What is half wave and full wave rectifier? So what is the definition for rectification? The process of converting AC voltage to DC voltage is called as rectification, and the device used for this process is called as rectifier. Now let us discuss the first thing that is called as half wave rectifier. What is the first thing? That is called as half wave rectifier. So first of all, what you are supposed to do, you are supposed to draw the diagram. Diagram is very important, circuit diagram. Carefully see this diagram. First, what you are supposed to do, you are supposed to draw the diagram. By looking at the diagram, you are supposed to write the answer. Here, what is the diagram for half wave rectifier? Here I am considering an AC source. I hope everyone know the meaning of this symbol. What is this symbol? कौन से डिवाइस का सिंबल है ये? See here I'll be using a diode, PN junction diode, and here finally I am taking the output here. This is called as output resistance RL. Finally I am taking the output here. This is what? This is called as diode. Which type of diode? PN junction diode. This is AC source. What is the name of this? This is called as transformer. I hope everyone knows. This is called as what? This is a symbol for transformer. So what is the first thing you are supposed to write by looking at the diagram? What is there? Only one diode is used in half wave rectifier. What is the first point you are supposed to write? Only single PN junction diode is used. Where? In half wave rectifier. Used in half wave rectifier. What is the first point you are supposed to write? Only one PN junction diode is used in half wave rectifier. Now carefully see here. I am trying to draw the input and output cycles for this. See here. See here. Everyone carefully see here. I am taking this one as input voltage and this is output voltage. Which type of source we have given? We have given alternating current, alternating voltage. So we know that alternating means we generally will be considering sine function. You can consider cos function also. Assume that the input voltage is going something like this. Input voltage is going something like this. Now let us see what will be the output. Output कैसा आता देखेंगे हम लोग यहाँ पे. See here carefully. Whenever this is called as positive cycle, this is called as negative cycle. Whenever positive cycle is there, the point here will become We know that this is P side of PN junction diode. This is N side of PN junction diode. This will become positive during positive cycle. This will become positive and this will become negative. Whenever for a diode, when P side is connected to positive terminal of the battery and N side is connected to negative terminal of the battery, this type of connection is called as what? Forward bias. During forward bias, any current will flow or not? Means definitely yes, the current will flow in forward bias. So see here, what is the first point I am going to write? During positive, which type of cycle? Half cycle or full cycle? This is half cycle only. During positive half cycle, the diode is in forward bias or reverse bias? Is in forward bias. And whether the current will conduct or not, the diode will conduct or not? Yes, the diode conducts. The diode conducts. So what is the second point you are going to write? What was the first point? Only one single diode is utilized in half wave rectifier, and during positive half cycle, the diode will behave like a forward bias connection, and in forward bias connection, whether the current will flow or not? Yes, definitely current will flow. So whether I will be getting the output or not? Yes, definitely I will be getting the output. The output will be something like this. For positive half cycle, we are getting output here. Okay, now let us see for negative half cycle what will happen. Let us see what will happen for negative half cycle. See here. For negative half cycle, what will be happen? See here. This terminal will become negative and this terminal will become positive for negative half cycle. Now see here, what is this connection? Whenever P side of semiconductor is connected to negative terminal of the battery and N side of semiconductor is connected to positive terminal of the battery, what will happen? The diode will conduct or not? The diode will not conduct. Whether I will be getting any output? I won't get any output for negative half cycle here. In which case? In case of half wave rectifier. So what is the next point you are going to write? The next point which you are going to write is third one. During negative half cycle, during negative half cycle, the diode is in reverse bias. Whether the diode will conduct or not? No, the diode does not conduct. The diode does not conduct. I hope you understood till here, because finally we are supposed to write 1 point. By that we can finish this answer. So in half wave rectifier, what we are using? We are using one PN junction diode, and during input cycle, whenever the cycle is positive, the diode will behave in forward bias. In forward bias, the diode can conduct current. During negative cycle, the diode will behave like a reverse bias. Whether it will conduct any electricity? No, it does not conduct any current. So in the graph, we'll be getting only positive cycle. There won't be any negative cycle. For the next positive cycle, what will happen? Again, the diode will become positive and we'll be getting the output here. So the output waveform will be something like this. Only we will be getting half wave. That is the name of this device, half wave rectifier. In case of full wave consists of positive cycle and negative cycle. Only half wave has been rectified. Only that wave for which the diode is forward bias. For the diode in reverse bias, any wave is being rectified? No, because the diode does not conduct in reverse bias. I hope you understood till here. Finally, if I supply 100% AC, how much amount of AC will be converted into DC? Means the efficiency of half wave rectifier. Efficiency of last point. Efficiency of half wave rectifier is 40.6%. What does it mean? If you are supplying 100 units, out of those 100 units, only 40.6% will be rectified. By which type of rectifier? Half wave rectifier. I hope everyone might have understood this answer. By taking this answer, we can also understand the full wave rectifier. Please note down this. Once we are done with this, I will move on to the full wave rectifier. Note down all these points. Half wave rectifier, the device used for rectification is called as rectifier. In half wave rectifier, what is there? Only one single PN junction diode is used, and during positive half cycle, the diode will be in forward bias and it conducts current, and during negative half cycle, the diode will be in reverse bias and it does not conduct. And what is the efficiency of this half wave rectifier means? Efficiency of half wave rectifier is 40.6%. What does it mean? Whenever you are supplying 100% of 100% AC, out of that 100% AC, how much percentage it can rectify? It can convert to 40.6% DC. Out of 100% AC, it can conduct 40.6% into DC. I hope you understood this answer. Let us move on to the next question. What is the next question? Full wave rectifier. Full wave rectifier. I'm turning the page. So the next question, important concept in semiconductor devices is second one. Full wave rectifier. Full wave rectifier. See here. Again, first of all, what I am doing, I will be drawing the diagram. By looking at the diagram, you are supposed to write down the answer. So see here. Again, I am considering a source. Which type of source? Alternating voltage source. Again, I am having here a special type of transformer. Remember this. A special type of transformer. It will be something like this. Carefully see this diagram. A special type of transformer. What is the transformer? I will tell. So here in half wave rectifier, we have utilized only one diode. Here we'll be using two PN junction diodes. Here I'm writing this one as diode D1. I'm having one more diode. This diode I'm writing it as D2. Finally, I will be using a special type of transformer that is called as here. Here I will be taking the output. Here I will be taking the output. This is called as load resistor. RL represents what? Load resistor. From there we'll be taking the output. Here we'll be calling a special transformer that is called as center tap transformer. This is called as a special type of transformer. What? Center tap transformer. So here itself, I am drawing the input and output waveforms. Here itself, I am drawing input and output waveforms so that you can write directly below this. You can draw this directly below this. So this is one axis. This is input. Again, I will be drawing the output below itself. Or I will be taking further more line for explaining you so that you can easily understand. I hope you are able to see this diagram. I'm expecting that you are able to see this diagram. How will be input? Here I am taking input. It will be alternating source. So I'm considering sine wave here. Here we'll be having outputs. These all are outputs. You will understand this. You will understand this. Don't worry. See here. Everyone carefully see the diagram. So see here, in case of half wave rectifier, what was the first point that we have written? The first point that we have written in half wave rectifier is it consists of one single diode. But in case of full wave rectifier, two PN junction diodes are used. Diodes are used. This is the first point which you are supposed to write in full wave rectifier. What is that? Two PN junction diodes are used in full wave rectifier. Next, what is that next point? What is the second special point is there? A special transformer is used. Is used. What is the name of that special transformer? I have already written center trap or central trap transformer. It is also called a center trap transformer. So what is the first point you are supposed to write in full wave rectifier? In full wave rectifier, two PN junction diodes are used. What is the next point you are supposed to write? A special type of transformer known as center tap transformer is utilized. Now see here, what is the third point? This is positive cycle. This is negative cycle. This is positive cycle. Now everyone see the working of this full wave rectifier. See here. Next, third point I am writing. During positive half cycle, during positive half cycle, let us see what will happen. Everyone carefully see here. During positive half cycle, what will happen is that here this terminal will become positive. This terminal will become negative. And for this particular region, this will become positive and this will become negative. See here, we are getting two loops here. This one is becoming positive, this is becoming negative, and here it is becoming positive and here it is becoming negative. See here, what will happen? This is positive and we know that this is having P side and this is N side. So P is connected to positive terminal. Here the P is connected to negative terminal. So during positive half cycle, what is happening here? During positive half cycle, diode D1 is in which bias? Forward bias or reverse bias? When P type of the semiconductor is connected to positive terminal of the battery, it will behave like a forward bias. Whether it will conduct current? Yes, it will conduct current. Here P side is connected to negative terminal of the battery. Whether it will be forward bias or reverse bias, it will be in reverse bias. Whether it will conduct electric current? No. So in case of positive half cycle, D1 is in forward bias. Forward bias and conducts whereas D2 is in reverse bias, whether it will conduct or not, and it does not conduct. I hope you understood this point. During positive half cycle, what will be happening? Only diode D1 will conduct, whereas diode D2 will not conduct. So how is the output waveform I will be getting? I will be getting the output waveform only due to which diode? Only due to D1 diode. Whether D2 diode will conduct any current, it won't conduct any current because it will behave like a negative cycle. Now see here, what will happen? Sorry, reverse bias. Now see here, what will happen for negative cycle? Carefully see this. Third one, fourth one. During negative half cycle, let us see what will happen. During negative half cycle, let us see what will happen. During negative half cycle, this terminal will become negative and this terminal will become positive, and here again it will become negative and here it will become positive. This terminal is becoming negative, this terminal is becoming positive. So see here, P type is connected to negative terminal of the battery. Whether the diode will conduct? No. Here P type is connected to positive terminal of the battery. Diode will conduct? Yes. So in this case, during the negative half cycle, D1 will be behaving in reverse bias and D2 will behave like a forward bias. Whether the current will conducted in D1? No current is conducted by D1 diode, whereas current is conducted using D2 diode. So see here, what is the next one I can write? During negative half cycle, D1 is in reverse bias, and does not conduct, whereas D2 is in forward bias, and it conducts, So here the output I will be getting during negative half cycle is because of the D1 diode or D2 diode? It is because of D2 diode. So in case of one complete cycle, in positive cycle also I am getting the current. In negative cycle also I am getting the output. See here, full wave I am getting here. That is the reason we are calling this one as which type of rectifier? Full wave rectifier. When diode D1 is in forward bias, D2 will be in reverse bias. When diode D2 is in reverse bias, D1 will be in forward bias only for one particular cycle. So in both the cycles, during positive half cycle, during negative half cycle, both the cycles we are getting the output. That is the reason this is called as what? Full wave rectifier. I hope you understood this thing. And finally, you can write fifth point. What will be the fifth point? Efficiency. What is the efficiency of a full wave rectifier? Efficiency of full wave rectifier is 81.2%. 81.2%. What does it mean? It means that whenever you are supplying 100% of AC, it is converting around 81.2% into DC. Because what is the use of rectifier? The use of rectifier is nothing but conversion of AC to DC. So in how many devices we have discussed that are in our syllabus? That is half wave rectifier and full wave rectifier. In half wave rectifier, what is the thing we are using? We are using only one diode, and during positive cycle only it will conduct. During negative cycle, it will behave like a reverse bias, and there is no conduct of current. So finally, I can say from the entire full wave, only half wave is being rectified. And what is the efficiency of half wave rectifier? Means 40.6%. But next we have discussed regarding full wave rectifier. In full wave rectifier, how many diodes we are using? We are using two PN junction diodes and a special type of transformer that is called as center transformer or central tap transformer. And during positive half cycle, diode D1 is forward bias and diode D2 is reverse bias. And during negative half cycle, diode D1 is reverse bias and D2 is forward bias. If I combine the entire cycle, I am getting the output both for positive half cycle and negative half cycle. And finally, I came to know that efficiency of full wave rectifier is how much? 81.2%. 81.2%. Let us finish today's class here itself. Tomorrow we are going to discuss one or two more questions from this chapter. That is logic gates, that you may expect a question as what is the NAND gate, what is NOR gate, what is NOT gate. So hopefully you are understanding this class. So we'll meet tomorrow. Thank you.